everyone. For today's lesson, we are going to get started on a new unit. That new unit is called Quadrilaterals and Coordinate Proofs. Our first lesson is called the properties of parallelograms, which a parallelogram is a very special type of quadrilateral. Our learning targets for today are for you to be able to say, I can identify and apply the properties of parallelograms to solve problems. Now, a quadrilateral is a four-sided figure. So we're going to be referring to this thing called a quadrilateral chart. And these are all of our very special quadrilaterals that we have. And so in our quadrilateral chart, what you're going to see is that a quadrilateral has four sides. And all of the figures that come off of that quadrilateral, that general quadrilateral shape, will be more specialized quadrilaterals with their own properties. So let's go ahead and start off today by defining a quadrilateral. A quadrilateral is a four-sided figure whose angles add to 360 degrees. So just like when we were working with triangles, all of the angles of a triangle add up to 180. All of the angles of a quadrilateral add to 360. And it is any four-sided figure. So if you have a figure with four sides, we call that a quadrilateral. But there exists very special quadrilaterals. The first quadrilateral that we are going to discuss is the one that is in the middle of our chart. This one's called a parallelogram. Parallelogram. A parallelogram is a quadrilateral with two pairs of parallel sides. And look at that. The word parallelogram has the word parallel in them. So parallelogram is a quadrilateral with two pairs of parallel sides. So what you're going to see in a parallelogram is you will see that you will have a shape and you will see arrows that will indicate that the opposite sides are parallel. So I normally do this at the very beginning of my lesson. I always say what materials you need. So I'm going to make sure I talk about that right now. To continue with this lesson, you're going to need obviously something to write with. I strongly recommend that you have colors. You're going to need a glue stick, some scissors, and you're going to need our cutouts for parallelograms. Make sure that you have those ready before continuing with this lesson. The first thing I'm going to start with is the parallelogram that you will have cut out. So I'm going to go ahead and paste this parallelogram right here in my paper, like right below the definition of a parallelogram. And I'm going to be marking up this picture as I go. Starting with the definition of parallelogram. So because I know that a parallelogram is a quadrilateral with two pairs of parallel sides, I'm going to mark up those parallel sides by inserting arrows. Not just so we know that parallel lines do not intersect each other. And these sides are called opposite sides because they are across from each other and do not touch. These sides have the same exact definition. They are going to be parallel to each other as well. They do not touch each other. They're on opposite sides. So we call that opposite sides are parallel. So that's what this means. I'm gonna call it right here. Opposite sides are parallel. Opposite sides are parallel. So I have that in blue. But they have additional properties that we are going to be talking about. So one of the very special properties that parallelograms have, in addition to their sides being parallel, is that their opposite sides are congruent. So like this length right here is about 10.2 centimeters, and this length right over here is also about 10.2 centimeters. This side over here is about 4.8 centimeters. And this length over here is about 4.8 centimeters. So the opposite sides are congruent. So I'm going to go ahead and take my pen and I'm going to mark up using tick marks that the opposite sides are congruent to each other. Next, in a parallelogram, we talked about opposite sides being parallel, opposite sides are congruent, and now we're going to talk about the angles. So what we have here, because we have parallel lines, we have these angles that are considered consecutive interior angles. We learned about this in a previous unit. These consecutive interior angles are going to have different arc marks. And we know that consecutive interior angles are supplementary because they're between parallel lines. So if this angle has one arc mark and it is supplementary with this angle that has two arc marks, that means that this angle with one arc mark would have to be supplementary to this angle over here, and I'm going to give it two arc marks because one arc mark would have to be supplementary with two arc marks. Two arc marks would have to be supplementary with one arc mark. And therefore, up here, these angles would have to be supplementary as well. And that's because we have two pairs of parallel sides, indicating that our consecutive interior angles are supplementary. So that means that they're going to add to equal 180. And that's something that we've talked about. But as a result of our consecutive interior angles being supplementary, we ended up with an extra property. And that extra property is that our opposite angles, the angles that do not touch each other, are congruent. We have these opposite angles over here with two arc marks are going to be congruent to each other. So opposite angles are congruent. So far we have opposite sides are parallel, opposite sides are congruent, and now the opposite angles are congruent, and the consecutive interior angles, all of the angles that are connected to each other along the sides, are supplementary. The last thing that we're going to talk about are the diagonals. So I'm going to go ahead and draw in the diagonals. Using my straight edge. And we're going to analyze them. So this diagonal is about 10 point, oh, hold on, sorry. Let me look at it. It's about 10.2 centimeters. And if I were to look at where the point of intersection is, the point of intersection is about at 5.1. Half of 10.2 is 5.1. So that indicates that these two segments are congruent to each other. Over here, this length, this diagonal, is about 12.4, with about 6.2 being at the midpoint. Now 12.4 and 10.2 are different lengths, so our diagonals are not congruent, but they intersect at a midpoint. And we know that midpoints cut a segment in half. So not points, midpoint. We know that a midpoint cuts a segment in half, and that's exactly what's happening here. The diagonals that are being cut in half by another diagonal, they cut each other in half. That word is bisect, and the diagonals bisect each other. Notice I'm using different tick marks because the diagonals are not congruent. So let's go ahead and make sure that we recap on what we just talked about here. And that's going to require our next cutout. So our next cutout, we have all of the properties of parallelograms. And so what I would like you guys to please do is please go ahead and put the parallelograms directly into the center and kind of make sure that if you were to fold it up, it would match right onto the line. That's what you want to see. And we're going to paste this directly into this like center box. So I have right here where I folded it up. And we're going to create tabs. So I'm going to go ahead and paste this right into this center box area. And I'm going to fold up, but do you see how there exists like a line right below? We're going to cut right just to the line. So just a quick snip going right up to the line. And a quick snip on the other side doing the exact same thing. And what that's going to do is it's going to create these tabs that will fold up and discuss what each of the properties are and kind of unveil what they are. So this is just a recap of just the properties of parallelograms. The first property that we have of parallelograms is that obviously this is a parallelogram, so we already know that the opposite sides are parallel. So I'll make sure that I write that down first. The opposite sides are parallel. So that is the symbol for parallel. It's not the number 11. It's our parallel symbol. So I'm going to write down opposite sides are parallel. But in addition to them being parallel, we have opposite sides that are congruent to each other. So I'm going to mark up those congruent symbols to show that they are indeed congruent. Opposite sides are congruent. So that's what I'm going to write down right here. Opposite sides are congruent. Next, we're going to look at the other property that we had. We had opposite, and if you look at the diagram, we are looking at angles. Opposite angles are congruent. So our opposite angles, if we were to look at these, we would have these two angles are congruent, and these two angles are congruent. Opposite angles are congruent to each other. So I'm going to write that down, opposite angles. So opposite sides are congruent, opposite angles are congruent. The next one we're going to talk about is consecutive angles. Remember that consecutive angles are all of the angles that are connected to each other. So you're going to see me use this like big huge bracket to show a connection. Like the measure of angle F plus the measure of angle G is 180. And that's because these are consecutive interior angles. They will be supplementary. That means that they're going to add to equal 180. So all of the angles that are connected to each other, going all the way around, these angles will be supplementary. They will add to equal 180 degrees. So I'm going to write that down up here. Consecutive, interior, angles are sup. They are supplementary. They add to equal 180 degrees. And they are consecutive interiors, so that means that they are connected to each other in between the parallel lines. Finally, we learn about the diagonals, and although the diagonals are not congruent to each other, they do bisect each other. They do cut each other in half. So although they are not the same exact, so this one has 2 tick marks, 1, 1. They're not the same length, but the diagonals intersect at a midpoint, and that midpoint indicates that they bisect each other. And remember that bisect means to cut in half. And so I know that we've talked about this idea a lot, but it comes up over and over and over again. So the diagonals in this case bisect each other. So I'm going to write that down. Diagonals bisect each other. I'm going to paste this directly into my notebook. And that is the end of today's video lesson. I hope that you now know all of the properties of parallelograms. We are going to be using these properties to solve other math problems, but if you have any questions over anything I talked about today, please feel free to email me. Otherwise, I hope you have a wonderful day.